Okay, we're going to keep going on solving these trig equations. So what we'll do is I'll go through the examples I did in class so that you have the examples to watch again. So here's the ones we worked in class. The first one, cotangent theta minus root 3 times 2 minus 2 times sine theta plus 3 equals 0. So the first one here, basically it's already set up. So again, cotangent theta minus root 3 times 2 sine theta plus root 3 equals 0. So what I'm going to do is this is already set up in the factored form. So I'm going to set each piece equal to 0. So sine theta plus root 3 equals 0. And then I'm going to solve for the theta thing. So in this case, I'm going to add root 3 to both sides. So this is going to give me that cotangent theta equals root 3. And this is going to give me a subtracting root 3, 2 sine theta equals negative root 3, divide by 2, divide by 2. Sine theta is going to equal negative root 3 over 2. So I got these two equations. Now I'm going to grab my unit circle. I'm going to go find out where does cotangent theta equal root 3. It equals it at pi over 6. That's one of the answers. So theta is going to be pi over 6. And what I had said in class was, I know the other one is also going to be something over 6. So I'm going to go check the other over 6s. 5 pi over 6. When I look at 5 pi over 6, it's negative root 3. That's not what I want. Come down here, 7 pi over 6. Yep, right there, cotangent root 3. So 7 pi over 6 is my other answer. So I have two answers for the first piece. I'm going to do the same for the other piece. I'm going to do theta equals. And I want to see where does it equal negative root 3 over 2. So I'm going to drag my finger around. Sine is negative 3 over 2 here at 4 pi over 3. And again, then the other one is going to be an over 3. And if I look over here at 5 pi over 3. So basically, I'm doing the same problem twice, doing the problem like we did twice. So that's how we do the first one. With the second one, we have tangent cubed x equals tangent x. To solve this one, as we did in class, what we're going to do is divide both sides by tan x, because what happens when I divide both sides by tan x? The right side goes in and divides out and becomes 1. The left side becomes tangent squared x. To solve that, I take the square root of both sides. And that's going to give me the tangent x equals positive or negative 1. So that tells me I'm going to look and see where does tangent x equal 1? Where does tangent x equal negative 1? I'm going to figure out these solutions. Again, back to my unit circle. As I drag my finger around, where do I see this tangent x equal 1? So look, tangent's going to equal 1 right here at pi over 4. So tangent equals 1 at pi over 4. And we know it's going to be another over 4. So I keep going. I look over here, 5 pi over 4, but that's negative 1. So that gives me one of these, 5 pi over 4. So it looks like all of them are going to be over 4. I keep tracing around. Oh, sorry, that's 3 pi. Sorry, this mistake. It's 3 pi over 4. 3 pi over 4. Come around to 5 pi over 4. It's a positive 1. So it's going to be at pi over 4 or 5 pi over 4. It's going to be at 3 pi over 4. And if we look, it's also going to be at 7 pi over 4. So in that case, it's going to be at all the pi over 4s, and that's because we're just looking for those ones there. Next one, 3. Cosine theta times tangent theta equals 0. This is where what I'm going to do is I'm going to use one of my identities. And my identity here is going to be that tangent theta is the same as sine theta over cosine theta. The cosine thetas divide out to 1, they cancel out. So we get sine theta equals 0. So what we're going to do is we're going to look on our unit circle where theta for sine equals 0. That's going to be here at 0 and here at pi. So it's going to be at 0. It's going to be at pi. It's also going to be at 2 pi. It's technically 3 answers there. Next, I'm going to jump to 7 because 7 is very similar to this one. So 7 is 2 sine theta equals cosecant theta. I'm going to use an identity here. So I'm going to say 2 sine theta equals 1 over sine theta. To get rid of the sine theta in the denominator, I'm going to multiply it. What's going to happen is the right side is going to cross off, become 1. The left side is going to become 2 sine squared theta. Divide both sides by 2. I'm going to get sine squared theta, theta equals 1/2. Square root both sides. And what I'm going to find out is that sine theta equals plus or minus the square root of 1/2. And using my rules of radicals, this is the same as root 1 over root 2 plus minus. It's going to be the same as plus minus 1 over root 2. And if you realize, if you remember from our little notes, that's going to tell me where sine theta equals positive or negative root 2 over 2. Remember, 1 over root 2 is the same as root 2 over 2. And if I drag myself around the circle, I'm going to find out that this is at all the 4s, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's where all those are going to be. So that's all using our identities. Now, number 4 is a factoring. It's a GCF situation. So cotangent squared theta minus cotangent theta equals 0. Excuse me. If I look at these, they each have a cotangent theta in common. So I can factor out a cotangent theta. When I do that, take it out of each piece, divide each piece by cotangent theta. Cotangent squared divided by cotangent is cotangent. Cotangent theta divided by cotangent is 1. So now what I can do is I can set cosine of theta equal to 0. I can set cotangent of theta minus 1 equal to 0. Add 1, add 1. That's going to tell me I'm looking for where cotangent theta is 0 and where cotangent theta is 1. Cotangent theta is 0 here at pi over 2. And using that same trick, I can also find out that it's also at 3 pi over 2. Now I need to figure out where does cotangent equal positive 1. Cotangent equals positive 1 here at pi over 4. And if you come down here, you'll find out it's also at 5 pi over 4. So theta is going to equal pi over 4 or 5 pi over 4. So that's going to be that one. And then the last one is a little bit about factoring. So I'm just going to do the one about factoring so that we have it. It is cosine squared theta plus 7 cosine theta plus 6 equals 0. And what I'm going to learn is this is very similar to if I were to look at x squared plus 7x plus 6 equals 0. What two numbers multiply to give me 6, add to give me 7? So those numbers would be 1 and 6. So that's how I'd factor this one. This is factored the exact same way. It's going to be cosine theta plus 1 times cosine theta plus 6. Like I said in class, if you ever have trouble with the trig, just rewrite it as algebra and kind of look at it as algebra. That equals 0. So I'm going to set cosine theta plus 1 equal to 0. I'm going to set cosine theta plus 6 equal to 0. And in both cases, I want to get the cosines by themselves. So this is going to be cosine theta equals negative 1. 6 from both sides. This is going to be cosine theta equals negative 6. This never happens, so there's no solution for this piece. And this only happens at one place. It happens at theta equals pi. Answer that one is theta equals pi. It's the only place where that's a true statement. So that's how we do it with factoring. And then there's one more, is a little bit more of an involved factoring. And what I had said was, you don't necessarily need to sweat that one too much. I'm not going to ask that one on the test, but it is something that I wanted to show you so that at least you felt familiar with it. We're going to practice this more on Wednesday. There'll be another sheet and more practice. Please, again, make sure you feel comfortable with this factoring thing, specifically the greatest common factor and the real basic factoring, because those will appear on stuff we're going to work on. So please let me know if you have any questions.